Welcome back to Junior Scale Models. I'm Jason, your host, and I do models. We are in part 3 of this setting up a breadboard for my prototyping with a clock circuit, a pulse clock circuit, and I got a binary counter on here just because it works good with logic, feeding in resets and things like that. And on this one I have a slide switch to switch between the running the counter on the clock or on the pulse clock where I press the button to segment the counter. I'm going to switch that up, and I'm going to use a latching switch right here. So I'm going to plug that in here like so. And now I need to pull the output of each one of these into that wire. Okay, so I'm going to use the yellow. I'm going to strip the end that I need. I'm going to bend it down. I'm going to plug this into pin 3, and we'll make this one this, and we're going to go to the first pin, so we need to cut that roughly right there is where we want to go in. So 1, 2, 3, cut it. Alright, now that should fit after I strip it. It's not an exact science, but hopefully it is. So pin 3, first pin of that. Okay, that's that one. Now we need to do the same thing for the second output. Go ahead and use yellow again. So output there is going to go to the far pin, because the middle pin is going to go to our. So I have it right there, and I count over 1, 2, 3. Cut the wire. Put out. And you can use the box of breadboard jumpers and stuff, but for more semi-permanent, see, this one was way off. That was off by a whole entire hole. So I need to cut a little bit off of this. Restrip it. That's what's nice about this heavier duty 22 gauge wire is if you make a mistake, you can normally straighten it back out and rebend it. There we go. Now I want to plug this in a way where I have power and ground pretty easily accessible. I also want to make sure that pin 11, 12, 11 through 14 are directly across. So 9, 10, 11, 12, 13, yep, they are directly across. So plug that in there. We'll get some power wires. Power pins on this are pin 1. Pin 1 is VCC, and pin, I believe it's pin 8 on this chip. Yeah, pin 8 is ground. So bend our VCC wire, put that into there. you know, but when you place IC chips on a board, it can, you need to like see that ground is not perfectly straight, but if I moved it one this way to make that, one more this way, then my pin 11, 12, 13, 14 wouldn't line up with a ground pin, and that's a little bit more important because that's where my LEDs are going to come in. Now I'm using these 3mm blue LEDs because of their size, and I am going to bend the grounds on these. Do the ground wires. Let's get a black one. Bend that down there. We'll cut that off. And we'll plug that in to make sure it fits. Okay, so 9, 10, 11. So that plugs into 11 right there. So, but other chips need to be pulled to ground. So, actually 9 and 10 need to be pulled to VCC. So I need 2 more red. Now I have a video on the channel that'll be out soon on this TTL chip and how to set it up pin-wise and whatnot. I am just setting it up for this specific purpose because it does do more than just count. It has a way you can input things, and I'm just tying these to 5 volts for the sole fact that it's just going to count for me. That's all I wanted to do. I wanted to count against these little resistors, or these little LEDs. I said resistor. So I bent one of these wrong. So 3 of these. So this is just this is what I do when the camera's not on, after I made a video, or get a new product in and I need to set it up for use in videos or for working on projects. This board is actually going to be my the one I use that's not on camera. So this is going to be for just fun stuff for me and my son to mess around with. So he's starting school on Monday, so we're going to be out here doing a lot of stuff. So he's doing the online school. So let's get these cropped down a little bit. Wow, that is weird. Why did that unmute like that? That was weird. Okay, so we can plug these into these all crammed next to each other. They're small enough to where it's gonna, you're gonna see the counting process. It's not ideal. But you would end up jumpering off of these points to activate or reset or clear logic circuits after a time period, as in it counts up. So now from the switch goes to pin 2. So from the switch goes to pin 2. So let's get another piece of yellow wire here. Let's glitch it out. There we go. Pin that down. Come in here and we'll go from there to pin 2, which is 1, 2, 3. This one may be a little short, we'll see. Oh, right on the money, pin 2. Okay, and then pin 1 needs to go high. So I'm going to use this one right here, because that fits in there. And then also pin 7 needs to go high. So that is too extreme. I need to get a different wire for that. And what I'll do is I'll just put the slightest little bend on it so I can still get my distance and still be able to pull it out of there. There we go. Still on the board. Still makes connection. The next pins, pins 3, 4, 5, 6 are not going to be connected. That looks like everything is connected. So let's power it up. Let's turn on the clock, and it's counting backwards. Oh, that's right. I forgot about this. It counts backwards. So it's counting backwards. That's right. I have to pull it off of here. So that stinks. I like it to count that way, but I can switch it to the make it count one button at a time. So that's interesting. Oh. Invert the chip and put the lights down here. See, on this other one, I ran the LEDs over here and then I just ran wires to them. I might end up having to do that on this one. So we'll see. But that's going to do it, guys. There it is set up. I got a program counter. Oh, there's one more thing I have to do here. I have to put in these breadboard jumpers to power the whole breadboard. This will be the last thing I have to do. So this one will go from this positive to this positive, like that. Then we'll go from this negative to this negative. Then we'll go from this positive to this positive, and then we'll come in here and do the negative now. And this just links all the boards, and if you don't want them linked, you can pull the ones you don't want linked out. And I like to do red on the outside all the way down, black on the inside. So and I don't need to tie these two together because they're already tied together with the power supply module. So you could, in theory, put one of these power supply modules on each board and have, you know, well, every other board you could put one on and then just run jumpers, but or you could do one here, one here, one here, one here, and it should, in theory, connect them all through, but it just seems like a lot of clutter for the board. So, and then now this will be my building surface here. I might run power to these rails here. I normally don't see a need for it when I use this breadboard power supply like that. So that is it. This was the shortest of the 3 videos, hooking this program counter up and having it work. You'll see this in other videos. This will be either use this one or the other one for logic circuits and all that good stuff. That's gonna do it, guys. Check out links on social media, Patreon, you know, hook it up, help me out if you can. If not, that's perfectly fine. But after that,